Okay, in this problem, we want to determine if the vector field is conservative. We have y squared times z cubed, comma 2xy times z cubed, comma 3xy squared times z squared. And on the right is the reference that we'll be using. And in order to tell if something is going to be conservative for this vector field, we can say that if we have a continuous partial derivatives and the curl f is equal to 0, then f is a conservative vector field. So we'll be determining the curl. So like we did on the last video, we will set the first line is I, j, k, partial derivative in terms of x, partial derivative in terms of y, and partial derivative in terms of z. And then we write p, q, r. So y squared times z cubed, 2xy z cubed, 3xy squared z squared. And we simply do like a 3x3 determinant style. So I is going to be positive, negative j, positive k. It alternates. Positive I, negative j, positive k. So let's do that. So we write I, then we go diagonal. And we draw a box. And this is our box. So we have partial derivative in terms of y, bottom 2xy cubed, partial derivative in terms of z, 3xy squared z squared. So then we do minus j. The thing is, if you draw a box by going diagonally to the right, we don't have 4 terms or 4 elements. So we go left, these two, then go right, these two. So left is partial derivative in terms of x, and then y squared z cubed, then right, partial derivative in terms of z, then 3xy squared z squared. And then we do k. Thing is, by k, if you go diagonally to the right, we have no elements, no terms. So we go left, and we draw a box this way. So partial derivative in terms of x, then y squared z cubed, then partial derivative in terms of y, then we have 2xy z cubed. Okay, so now we're simply doing like a 2x2 determinant style. So partial derivative in terms of y for 3x y squared z squared. So we have y squared here. So we would get 6xy z squared minus partial derivative in terms of z for this 2xy z cubed. And we have z cubed right here. So we would get 3 times 2 is 6, 6xy z squared. Then minus j. So then we have partial derivative in terms of x times 3xy squared z squared. We have 1x right here, so we would get 3y squared z squared. Then we have a partial derivative in terms of z times y squared z cubed. We have z cubed, so we have minus 3y squared z squared. Then we do k. So partial derivative in terms of x for 2xy z cubed, and that's going to be 2y z squared. Then we do minus partial derivative in terms of y for y squared z cubed. So we would get minus 2y z squared. And I just realized this should be z cubed, and this should also be z cubed, because when we're taking the partial derivative in terms of y, we would get 2y z cubed. Likewise, this was 2x y z cubed, and we're taking partial derivative in terms of x, so it would also be 2y z cubed. And so now when we add everything up, we get 0, 0, 0, and since our curl is 0, we can say the vector field is conservative. And that's all we need to do.